So I hope you had some success in graphing this and filling out the table. So a quick summary, color, the 0 is -3, the multiplicity is 2, it's tangent to the x-axis, and here the 0 of 2, there's a multiplicity of 3. Because of the behavior, it's a point of inflection. The degree of this polynomial is 5, and the sum of the multiplicities is 5. So what we're going to do is, first step, we're going to write the equation of the polynomial in this form. Well, we don't know what the a value is yet, so we're just going to leave that at a. But I know that x minus b squared, it has to be that 0. So this is going to be x plus 3 squared, because it's a point of tangency. And I know this is going to be x minus, it's going to be x minus 2 cubed because of this 0. It's cubed because it's a point of inflection. All right, we are going to skip the higher multiplicities and the investigation on even multiplicities, and we are going to move right to here. I'm just going to do the summary. So if I have even and odd multiplicities, a real 0 of even multiplicity, so 2, 4, 6, or 8, occurs in a tangency. So basically, what we're going to be focusing on is multiplicities of 2. But a multiplicity of 2 looks like this. A multiplicity of 4 looks like that. 6, 8, any even number is going to end up at a point of tangency. And any odd number is going to end up with a point of inflection. So this would be degree 3, 5, 7, 9. But basically what we're going to be looking at is minimal degree for the most part. Let's look at class example 1. Without using a graphing calculator, make a rough sketch of the following. Well, I have 3 zeros here. That one, I know, is going to hit the x-axis at 0. This one is going to hit the x-axis at 1. And because of the 4, it is going to be a point of tangency. This is going to hit the x-axis at 4, and because it's degree 1, it's linear, it's going to go straight through. All right, so let's graph them. So I've got the 0 at 0, I've got the 0 at 1, and I've got the 0, there's 1, 2, 3, and I got a 0 at 4. Now let's connect with our end behavior here. If the leading coefficient is negative, we know, and the degree of this whole thing is 1 plus 4 plus 1, so it's degree 6. So arms are together. We know that these things are going to end up in these two quadrants. So let's graph it. I'm going to go straight through at the 0 because the linear factor is 1. At x minus 1, it's going to be a point of tangency. And at x minus 4, this thing is going to come straight through because it's linear. Now just connect the arms. And presto, we have the graph. Again, just a summary, we know this thing is degree 6. Therefore, the arms are together, and because there's a negative in front of everything, the leading coefficient is negative, so that puts the arms down here.